So I'm going to follow up with Joanne's talk, and you're actually going to see some echoes of what she said in my talk, which I promise you was not actually planned. So to start with, we're going to look a little bit at what's going on in the industry as a whole. So this is sort of the inflection point slide that you'll see coming up a bunch from Nokia. On the one side, you have a traditional communication service provider. So typically, we as an industry have focused on mass market elephant services. So things that we're going to have a huge appeal, a huge market appeal. They're going to be very large. The reason for that, of course, is there's a huge OSS tax. Every time we want to set up or configure one of these new services, you're going to have to make a huge IT investment. It's going to take a lot of time. 2-3 years is not unheard of. And it's going to take a lot of money in order to be able to set those up. You can't really go after a lot of small services. You're really focused on mass market services. As the technology's evolved, we're hitting this inflection point with cloudification, where the expectations for customers have changed. So now we're in a position, I can get an email in 2 minutes. I get Amazon can order something for me in 2 days. People want things now, right? And there's really no reason we shouldn't give them to them now. The faster we can deliver the service, the faster we recognize revenue. But in order to do this, though, there's going to be a significant infrastructure investment we're going to have to make to bring that speed into the networks. If we're successful, we can transition as an industry from a set of communication service providers to a set of what we're calling digital service providers. So the DSPs are going to be able to combine these cloud services with the communication services that you're offering today to address a whole new set of market opportunities. So to echo what Chen had said earlier, again, promise this wasn't planned, is that the telecoms market is largely flat. It's a huge business. It's about $1 trillion business globally. But also data's growing, voice is shrinking, video's flat. This has been the trend for the last few years, and we anticipate modulo a little bouncing up and down in the single percentages for it to be it moving forward. There has been a lot of value, though, captured over the top, right? And of course, we all look at the revenues of a Google or a Facebook and we go, oh, we want some of that. Now, we're not suggesting that CSPs turn around and try to become a Google. They're not built to that. They would not be any better at that than Google would be at being a service provider. Google's finding out that it's a little harder to be a service provider than they thought. However, there's a big and extremely lucrative market out there around the smart services. So smart industry, manufacturing, cities, transportation. A lot of these industries are still fairly slow, haven't moved that far along their own digital transformation at various different stages. Being able to access that market size would be fantastic. However, those markets also tend to be pretty fragmented. So they're not those mass market services where I can make an easy business case to go and justify the investment for support systems to fully automate it, right? I pick an AT&T, right? Uverse, if you subscribe to Uverse, it's a pretty automated system. They did a fairly good job with that. They have nearly 1,000 OSS systems supporting that as a huge investment. You can't do that if you want to target ports, for example, right? If you want to go target the Port of Oakland or the Port of Los Angeles or Antwerp or wherever it may be that has a large port facility, you can't afford to make that huge OSS, that 1,000 system OSS investment in order to do that. You need to be able to rapidly bring those new services to market or customize the services that you have. So this is really, at the end of the day, about connecting the business that we have to the network that we're providing to be able to increase the revenues and increase the profitability. So here we have sort of the curve chart of how things are getting more expensive before potentially, hopefully, they're getting less expensive. So first we decided we introduced network virtualization. But, and as Joanne illustrated brilliantly in her talk, that makes things more complicated. I've now added another layer, and in addition to adding a layer, I've made other things dependent on that layer. So that's going to increase my complexity and my operational cost and increase the fragility of my network. Now we're talking about 5G. We're talking about network slicing. And getting into some of those smart services is going to require network slicing. It's fantastic. It'd be great if I can go into that port and go, I'm going to give you a RAN slice for your drone security. So you fly that drone around, you have dedicated RAN resources to make sure you've got your streaming videos set up, right? That gives me a whole new revenue stream. But if I'm slicing that stuff manually, that's a lot more operational overhead. So my TCO for each of these incremental ads is going to start going up. Now, the solution, of course, to this is how do I automate this? How do I get to the point where setting that new service up is a matter of a couple of seconds to click something, or if I have to design a new service, it's a matter of a couple of days to think it through and set it up in the system. Now that's your green curve here, right? That's the where we want to go. Given transaction costs, there's always we're not going to follow the green curve perfectly. We're going to go a little bit up the blue, but you want to keep it as close to the green curve as you can by automating the systems as you're going along. And moving forward with introduction of virtualization and introducing network slicing. So in order to do this, we have multiple control loops. So you take this automation, you split it open, and you realize, wow, there are lots of different control loops going on, and they're operating at different scales in terms of different number of devices, there are different time scales, there are different levels of expertise that are required for each one of these control loops to be able to work effectively. And you want to drive those control loops as close to the functions as you reasonably can so they respond more quickly and so they can scale more effectively. So if we look a little bit at how we move some of this along the capability maturity model, right? Where we are in the past was largely a reactive scenario. You'd come in and there'd be a single task. I want to set up a POTS line, right? And the system was very good at doing that particular thing, but that's all it did, right? It was very manual. Now we decided we want to be able to offer cross-network services, and this really started picking up with IP transformation. And by offering that too, we're starting to automate this, right? So we're starting to automate these systems, begin to bridge some of the silos. But things are partially automated today. We're not really there. We've gotten a little bit of cross-domain automation. And when that happens, the investment's still pretty significant. Where we run ahead, of course, is to the point where we get to the point of zero touch. I mean, it's the name of the conference, right? So where things operate in those closed loops, they operate quickly and efficiently, and then feed that stuff up into their parent loops on up to be able to pull off the rather complicated system that we have. What we want to do here, though, as we're moving these control loops forward, is not to do that in isolation. So if you have a single system, and I optimize this system, and that's great, but then I want to bring in another one, and how do those two interact with each other? And what happens when I want to bridge between the pieces? So you have to move forward with an idea and a plan, preferably, as to what that end goal is going to be. So as you're plugging and doing these additional automations, they can start functioning seamlessly together. And this is like Joanne's APIs, right? So if I define this particular domain with an API, and I define that API so I know what that piece of the domain is responsible for, when I come along with another piece of automation, I know where my boundaries lie, and I can start automating those additional pieces. So as we move from our traditional domains, the CSP domains, to our DSP domains, the OSS systems, the traditional OSS systems, are going to start to transform as well. We're going to go away from some of the monolithic OSS we have today and the carefully orchestrated, very carefully balanced spaghetti systems into a more loosely structured, loosely coupled system where the pieces are able to glide more effectively and integrate cross-domain. And for lack of a better name, we've been calling this digital lifecycle, service lifecycle management, which is a bit of a mouthful, but I think it sort of effectively describes what it is you're trying to do. Now, next question, of course, is how do we pull this off, right? So what is that framework that we're trying to get to? So the framework itself is really it consists of two layers. You've got a matrix that's 2 rows and 3 columns. Is the simplest way to think about it. You have your service orchestration and service assurance that sits across the top, and that handles your cross-domain portions of the network, right? So anything that goes between domains is going to get handled by your service. Below that sits your set of network domains. We sort of show that as kind of like pages here with this 3D. I know you can sort of a little hard to read the tiny font, but effectively you have those individual domains, and those domains handle what they're good at. And one reason to do this, of course, is to be able to swap domains potentially, and the service layer acts as that glue for you. Another reason is expertise. So traditionally, service or vendors, right, have said, I've maybe built a wireless EMS. It does wireless EMS pretty well, right? They've got a lot of expertise in that domain. They want to go outside that domain. It's very difficult for them to do that, right? That's not where their expertise lies. If you're an OSS provider, you're an IT shop. You want everything, you manage things as generic objects. You want to have as big a market as possible, so you're not necessarily a telco specialist. You're going to try to sell that OSS orchestration software to anyone and everyone, which also means, of course, you don't encode a lot of expertise there. You don't really know exactly what's happening down the network. So, in order to integrate that, it requires a huge integration burden, because as a service provider, you have to take that generic software and you have to teach it about each of those particular domains and teach about those domains in your particular environment. By separating that into two layers, then you can take the expertise for the domain, and then you can take the expertise for coordinating amongst domains. And effectively, by having the two pieces separate, each piece of software can do what it's most effective at doing. Now, if you look at the columns, and I don't really have this drawn out as columns, there's sort of text on the right side. One side is your orchestration stack, which focuses primarily on fulfillment, new service creation, deployment. The other piece is going to be your assurance piece, what happens when it breaks. And then the third column is your shared data. So your Hadoop database, your analytics, log files, your shared topology. And each of the domains will have their own topology function, but having a cross-domain topology function allows you to manage things as a service, right? So I understand now, for example, how my data service routes over my IP, routes over my optical network, routes over my physicals, right? My fiber and my conduits. Each of those tends to repeat. It's kind of fractal, so each of the domains has those functions as well as the service function as a whole. Now, the way you implement it, there are multiple ways to implement this. You can implement it as individual systems. You can implement it as microservices. You can share some of the services. There's a lot of devil in the details here to make the thing scale most effectively, cost effectively, as well as technologically effectively. But that's going to be the rough overview for the kind of system that you're going to be looking at for your next-gen OSS or your digital lifecycle management systems. Now, this is an eye chart, so I apologize ahead of time. But effectively, what we're doing here is we're moving from the left to the right. So along the bottom is the time axis. So we start with traditional systems, which we discussed a little bit earlier. I have vendor EMS, I want to set up POTS, I want to set up optics, I want to set up whatever. You have complete verticality, complete silos, complete columns. And then as we go into, say, around 2000, when the IP transformation starts really taking root, the demand for those cross-silo services starts to take off. And therefore, the demand on the OSS systems to be able to provision those starts increasing. So now we start implementing partial integrations, spaghetti integrations, point-to-point integrations, in order to make it work, for that particular service. And that's where a lot of that expense and complexity comes from. Is that integration piece that we had to do to make multi-part services to work, so you get one bill, so it looks at least to the customer like it's one system and service. Then around, I guess, 2012, more or less, we started talking about network function virtualization. We started moving these services in and saying, well, what if we can do stuff with cloud? What if we offer server-based functions? What if I can virtualize my firewalls? What if I can do, I can offer them some sort of cloud functionality or storage services or whatever else it might be? And the chart gets more complex. You add all the bright blue stuff on top of that. You add all that additional complexity that those functions have to ride on top of something. It gets even more complicated. And that's the increasing spaghetti that we're getting to. And in order to fix this piece, we're going to have to move into that next portion, right? We're going to have to say, how do we separate the domain and service managements? How do we separate these particular functions? Recognizing that they're going to move over time and that our own integration is going to move over time. So we want to be able to do it piecemeal because we can't do it Flag Day. That would be another disaster to get to where we need to go. Okay, so this is question, of course, is how does this fit into the big picture? So this is what Bell Labs calls the Future X network architecture. I'm sure some of you have seen it before. It's pretty heavily marketed, where it just basically shows you how all the different parts of the next generation network fit together, right? So we start with access and network on the bottom, and it moves up. But really, this piece is that fat middle piece. So if I've got the business at the top of the diagram, and I have my network at the bottom of the diagram, connecting that piece goes through this next-gen OSS. It is the programmable network OS. It is the automated cognition systems that provide the network intelligence for that sort of service level assurance and provisioning. That big fat part in the middle, if we don't have that and we don't get that right, then moving into the forward and connecting that future business to that network is going to be extremely hard and very expensive. And the risk, and it's very real risk, is that your competitor gets there significantly faster than you do. Their operational costs drop. They can get stuff to market more quickly, and therefore you're at a competitive disadvantage. Now, how are we going to get there as an industry, right? Because this is really an industry problem. This isn't just a Nokia problem or a single service provider problem, right? We as a community have to be able to pull this off and effectively move forward together. So this slide tries to encompass all the various different moving parts that we're going to have to work together on. Now, the new ETSI ZSM initiative, we have a lot of hope there. We're participating heavily there because I think that's a good place to drive some of those architectural and framework descriptions that integrate the standards from places like TM Forum or 3GPP or IETF or the other sorts of pieces that are providing parts of this solution into that important framework. Because if we can all agree on a common framework and some level of common APIs, it's much easier for vendor community to write the software, and it's much easier for the operator community to integrate and deploy the software with some level of commonality. So just to sum things up, we've got to automate the network. This is going to be hard. We've all tried this before. This is not an easy road. It's going to be a lot of heavy lifting involved. The automation is going to be most powerful when we're able to glue it together and offer things that cross those domain boundaries, that cross those silos. Service providers might want to consider some sort of CEO reporting chief automation officer structure where they can break those silos depending upon how strong they are in your organization. In order to be able to do that, we're going to have to introduce new architecture. That architecture is going to be centered around those sort of 2 layers and 3 columns that I was talking about, where you separate your service management and your domain management, and you have that loose coupling with a clean interface between them. And at the end of the day, we're all in this together, and we're going to have to make sure that as an industry, we're able to move forward. Now, the last slide, and the one I'll leave up here, is the gratuitous marketing slide. So we're doing a little bit of this. We've obviously made some significant investments. We bought Comtel. We've got indigenous development. We obviously have a lot of domain expertise. So if you got a chance, stop by next door, take a look at some of the stuff that we've got. So I have a couple minutes for questions, if anyone has any. No? Terrific. Thank you, everyone. I appreciate your time.